So for question 7, it just said randomly select 5 of the 30 salaries and compute the mean. And then it also, before that, it said you could go to random.org. When I went there this morning, it was down. It's up now. So I don't know if we want to try putting those numbers in there or if you guys are good.
I'm good.
Okay.
Yeah,
I'm okay.
Okay.
We can do that. On our own doesn't seem very difficult to do.
So then it just had you take the 5 tiles that you selected and then compute the mean.
Right.
And then the next question gave us a graph, and you were supposed to draw like where your mean was out of the 5 that you got out of those boxes. And that you need to explain if your answer was unusual. And for mine, I got that my mean was a little bit greater than the mean on their like horizontal axis, but
okay.
And then it just said to compare our like answers so that we could see if any of them were unusual or if they were usual.
Yeah, I didn't get that far, so
Okay.
I don't have an answer to compare.
Okay.
I got 4,800 or 48,940 for my mean.
Okay, so yours was quite a bit bigger than mine. Mine was 47,900.
Mm-hmm.
Yeah, mine was 47,760.
So like if it's within 2 standard deviations, it's normal.
Right.
Is that right?
Yep.
Right, that was good.
And then for question 8, it just says it's talking about the GMAT, and it gives us that it's a normally distributed mean of 529 and a standard deviation of 113, and that it was a simple random sample for 10 students. So then it asks, what's the shape of the distribution of the sample means for all such samples? And I got that it's normally distributed because it was a regular population. And then how did you know that it was that it's going to have that shape? And same thing, because that it's the parent population was normally distributed. And then C said, what is the mean? And I have the mean as 529 because they gave us the mean. But then it says, what's the standard deviation of the distribution of sample mean scores for all such samples? And I wasn't sure how she got, I think, pulling up, she got 37 or 35.734.
So are you trying to find out how to get that?
Yeah.
So it's a formula, and you'll need to know what the standard deviation is. So you make your little, so the standard deviation of the
was 110 or 113.
Yes, right?
Mm-hmm.
And then you'll have to find out what your N, the letter N is.
Mm-hmm.
Which
So
is
that'll
10.
be 10, right?
Yep, it was 10.
And so what you'll need to do is get the standard deviation and you divide. So it'll be standard deviation over the square root of the letter N.
Right.
And then you'll get it. You just have to make sure you get the square root first and then divide. Like if you use a graphing calculator,
mm-hmm.
or a calculator that has parentheses in it, it'll be right.
Okay, so 5. Wait. Sorry, hold on. I got 49.76. Is that what? I thought it was 53 something.
It's 35.
5. I'll write that in. Okay. All right. I got it.
Okay. Yep. It took me a while to figure out. So, not to figure out, it's just finding that formula.
Yeah. I was like, wait a second. Where did that number come out of? But yes, that makes more sense. Okay. You guys want to move on to the quiz?
Yep.
Sure. Yeah.
This is lesson 6, right?
Yeah.
Yes.
Yeah.
One sec. I'm just logging. Good quiz. It's taking forever to load for some reason. Okay, so we got 1 and 2. I'll read question 3. When you are taking a sample size of n equal 5, what is the shape of the distribution of means histogram when the parent population is skewed right? Isn't it still skewed right? Like,
What I would say. It would be skewed right.
Yeah.
you guys agree?
Yep.
Yeah.
Okay. All right, somebody take 4.
When you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is skewed? Is right. Would it be normal?
Okay.
Say normal, yeah. The average number.
Okay, if we, hold on, where, I think we can throw it into that little, that in the reading, hold on, 1 sec. I'll just throw it in to make sure. So it asked us, what was n? Sorry. N is 100.
Yep.
N's 100.
Do 100. No, it won't let me do it. Okay, just kidding. It only lets me go to 25. But even with right, right skewed. Is that what you guys are getting? Do you guys?
Yeah, I have skewed right as well.
You guys want to go with that?
Mm-hmm.
Skewed right.
Yeah.
All right. Somebody want to take question 5?
Yeah, I can take it. When you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
Then it should just be normal. Right?
I would think so. I don't know if these are like.
I don't know why they're being tricky, but I feel like whenever I did it in those sampling distribution charts, like if you had it skewed right, then it was skewed right. If you had it normal, it was normal.
Yeah, that's what I think. I don't know why they're asking him like this.
Do you guys agree?
Mm-hmm.
Yeah, I agree.
Okay. Okay, so 6, when you're taking a sample size of n equals 100, what's the shape of the distribution of means histogram when the parent population is normally distributed? It should still just be normal.
I believe so.
That's what I have.
So it just says if the parent population is normal, then the sampling distribution of X will always be normally distributed.
Okay.
That's the, like that's, I'm just looking in the reading. And then if the parent population is almost normal, then a sample size n equals 5 will probably be sufficient to assure that X will be approximately normally distributed. And then if the population is heavily skewed, then it will require a larger sample size to be assured that X will be normally distributed. For most moderately skewed distribution, a sample size of around 30 is traditionally thought to be sufficiently large to assure that X will be approximately normally distributed. This is not a definitive number, but it's the rule of thumb. So maybe it's the ones that are 5 are not going to be normally distributed. Well, yeah, right?
I thought it said 5 would be normally distributed.
It says that it needs to have a sample size of around 30, so anything greater than 30.
Greater.
So it says there are 2 ways that X can be approximately normally distributed, and that is X will be normally distributed if the data were drawn from a normal population and will be approximately normally distributed if the sample size is sufficiently large. So I'm wondering if the 100s mean that they're still, that they're normal. Yes, no? What are your thoughts?
If it's, so you said if it's heavily distributed, then it's normal?
If it's greater than 30.
The symptoms are approximately normal. Okay, yeah. Okay, so I just saw that in the textbook right here.
Yeah.
Yeah, then I guess that would make it normal.
Right? Is that what you guys,
Even,
that's kind of what I
if the parent population is not normal. So even for number, which one is it? Number 4, it would be normal then.
Right. That's what I'm wondering. If it's the 100, then it should be normal.
That's what I'm reading.
But if it's 5, then I'm thinking it's skewed.
That's what I'm reading.
Is that what you guys are reading?
Yeah.
Max? Okay, so then, is that, okay. So that was 5. You right, 5, and then it will be normal. Okay. All right, do you want to read 7?
When would the distribution of means be normally distributed? When data are drawn from a population that is normally distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample size is large. Data are drawn from a population that is right skewed and the sample size is small. Or data are drawn from a population that is right skewed and the sample size is large.
Okay.
So
So go ahead.
I was just gonna say, so if it's large, then it's normally distributed, right?
Right.
Yeah.
So B, right?
Yeah.
Okay.
This, we can collect multiple ones, can't we?
Yep.
So then would the fourth one be true also?
That's what I'm thinking.
And would there be a third one, or
I think the last one works because it said even though it could be heavily skewed, as long as there's enough
Large.
sample size large, then it'll be normally distributed.
Agreed. And I don't think that, I think if it's ever small, I don't think that it's, well, if it's drawn from a population that's normally distributed, then shouldn't it still be normal? Let's see. Yeah, will be normally distributed if the data were drawn from a normal population. I don't think size matters. Right?
like size matters if it's
right, if it's skewed, right? But if it's
not large.
normal, if it's drawn from a normal distribution, then it should still be normal, right?
Mm-hmm.
Yeah.
So we should do A, B, and D.
Yeah.
That's what I'm thinking. Yeah.
Yeah, the large number states that the sample size gets larger, the sample mean will get closer to the population mean.
Yeah, so the central, so the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. This is called the central limit theorem.
Yeah, I think it's just this A, B, and D.
For question 8?
Oh, sorry, we're on question 8.
Oh,
That's what you were. Sorry.
what did you guys put for 8? Sorry.
I'm reading it now. Sorry, I thought we were still on 7.
Oh, no, for 7 we did A, B, and D, right?
Yeah.
Yeah.
Okay. So then the central limit theorem, the definition states that if the sample size is large, the sample mean will be approximately normally distributed. That is it.
Then it has to be D.
Okay.
Yeah, that's about right.
Okay.
Okay, next one.
Go ahead.
Are you ready for the next one?
Yep.
Okay, let X be a random variable with a population mean 10 and a population standard deviation of 6. Suppose a sample size n equals 36 is drawn from this population. So I guess the mean is 10.
Yeah, the mean would be 10. And number 10 would be 1, I believe. Because
What is the standard deviation?
How did you get 1?
so the standard deviation is 6. So then that would be the top number. Then you would put that over the square root of n.
36. Okay. Which equals 1.
Yeah.
Gotcha.
Sure.
Okay, that makes sense.
I thought it was, yes, you're right. So it's 10 over the,
No, it would be,
It'd be
6
6.
over the square root of 36.
right, yes. And so then it's 1.
Yep.
Yeah.
Yep.
Okay, that makes sense.
So it just says, regardless of the distribution of the population, if the sample size is large, what would the shape of the distribution, and it should be normal, right?
Because it's larger than 30.
Yep.
Yes.
All right, so right.
Yeah, it just says, even if the parent population is not normal, the central limit theorem guarantees that the distribution of the sample mean X will be approximately normal if the sample size is large enough. For this course, if N is greater than 30, we will say the distribution of the sample means will be approximately normal.
Okay. Sweet. So that's normal.
And then what theorem would justify your response to the last question? So,
I don't think they have a law of large numbers.
no, there is.
Is there? Let me see.
Yeah, the law of large numbers states that as the sample size gets larger, the sample mean will get closer to the population.
Together. Which,
The distribution of the sample mean is normal.
but so it should be the central limit theorem, because that's what we just used to figure out the one before.
Yes.
Yeah.
Okay. All right. You ready to submit?
Yep.
Oh, yeah.
We got them all right.
Wait,
Nice.
boys.
We did it.
We did it. Okay. So on Wednesday, I mean, it shouldn't be a problem. I have another group that has to meet on Wednesdays at 2:30. So I think, I mean, we don't usually take more than an hour. So are you guys still good to meet Wednesday at 1:30, or do we need to switch that?
Okay, we're gonna yeah, meeting on the Wednesday.
Okay.
Wednesday would be good. 1:30.
Yeah. I think, yeah. I'm trying to think of when I work.
Okay.
Yeah, I work 9 to 11, so I'm good.
Okay. Do you guys, if we did it at 1, just to be safe, would that be okay?
Yeah, that'd be great. I could do
Pretty
that.
good.
Is that good? Okay, let's plan on 1 just in case for some reason, but I think it should.
We should just send a reminder text just in case.
I will.
Okay.
I'll shoot you guys a text and just make sure.
But yes, that 1 o'clock should work perfect.
Okay. Awesome. We'll see you Wednesday then.
Sounds good.
All right. Bye, guys.
All right. Bye.